In this video, we kick off our Unit 6 on covalent bonding. So what is covalent bonding? So a chemical bond is the force that holds two atoms together and makes them function as a unit. We've already learned about one type of chemical bond, the ionic bond. So atoms form bonds to become most stable and to obtain an octet. However, in covalent bonding, electrons are shared between two or more elements, and it's always between two non-metals. So previously we were talking about ionic bonds, which were a metal and a non-metal. But covalent bonds are between two non-metals, which is why they share their electrons. It is never going to involve polyatomic ions. The bonding results from a mutual attraction of the two nuclei for the shared electrons. Not all electrons are shared in a covalent bond. They'll only share some of them in some cases, and we call those unshared electrons lone pairs. So how is covalent bonding different from ionic bonding? So an ionic bond is between a metal and a non-metal, and that metal completely gives up its electrons to the non-metal. Meanwhile, in covalent bonding, it's between two non-metals, and they are sharing those electrons back and forth. So it's each like they have an octet, but they both don't have an octet at the same time, depending on exactly where in the sharing we are talking about. So what are the properties of covalently bonded molecules? So they are poor conductors of electricity. They have a low melting points and boiling points. They tend to be soft, meaning that we can break them up easily or mold them easily. They tend to be brittle, so broken easily. However, they are also typically more flammable than ionic compounds, meaning that they are easier to catch on fire. Additionally, many do not dissolve in water well. We'll talk more about that later. So the rules for naming covalent compounds are different than the rules for naming ionic compounds. Most students find them easier though. When it comes to naming and covalent compounds, it's all about the prefixes. You look at the number of something you have in a formula, and you use that prefix to name it. So if you have 1 of something, it's mono, 2 of something, it's di, 3, tri, 4, tetra, 5, penta, 6, hexa, 7, hepta, 8, octa, 9, nona, and 10, deca. You are responsible for memorizing these prefixes. We're going to be using them so much, chances are you're going to memorize them anyway, but it doesn't hurt to have them completely memorized. So using those prefixes, let's talk about the rules for naming covalent compounds. So the first element in the formula is named first, and the full element name is used. The second element is named as if though it was an anion, so getting that IDE ending that we have already been working with. So element name, element with "ide" at the end. Then we're going to use those prefixes we talked about on the previous slide to denote the number of atoms present. So basically we're going to use the subscripts of our formula to figure out what prefixes to use. The prefix mono is never used for naming the first element. For example, CO is carbon monoxide, 1 carbon, 1 oxygen. It is not monocarbon monoxide. We only use mono on the second element, never the first one. So essentially it breaks down to prefix, with the exception of mono, first element, space, prefix, second element, ide. Pretty simple. I think you've got this. So if we have BF3, rule number 1, name the first element using the full name, boron. Rule number 2, name the second element as though it were an anion. So it's fluorine, so we make it fluoride. So rule 3 and 4 is we're going to use the prefixes to denote the number of atoms. So we have 1 boron atom, but we know we don't use mono for the first one. And we have 3 fluorine atoms, and the prefix for 3 is tri, which means we're going to get the name boron trifluoride. See how easy this is? I know you've got it. So I want you to pause this video and name the following covalent compounds all on your own. Seriously, pause the video and just see how you do. If you get it wrong, it's no big deal, but it's better to know you got it wrong than to trick yourself into thinking you understand it. So pause the video and come back when you're done. All right, let's see how you did. For number 1, you should have gotten nitrogen monoxide, 1 nitrogen, 1 oxygen. For 2, you should have gotten dinitrogen pentoxide for 2 nitrogens, because remember, mono is the only prefix we don't use on the first one. We use all of our other prefixes on the first one. And then the prefix for 5 is penta, so it becomes pentoxide. 3 is carbon dioxide. We have 2 oxygens. 4 is silicon trioxide. 5 is carbon tetrachloride, because tetra is the prefix for 4. 6 is iodine pentafluoride. 7 is phosphorus pentachloride. And 8 is tetraphosphorus hexahydride. How did you do? If you got them all right, awesome. If you got some of them wrong, maybe go back and watch the video again to correct those misconceptions early on rather than later. Now, when it comes to writing the formulas for covalent compounds, it is super easy. You use the prefixes as your subscripts. So whatever the prefix is, that's how many of that element you have. You do not have to crisscross. And even better yet, you don't have to simplify. You just leave it exactly what it tells you. So you're now being asked to write the formulas for the following covalent compounds. Let's do the first one together. So you have carbon monoxide. So since there's no prefix in the front, we know that means we only have 1 carbon. We see the prefix mono, which means we only have 1 oxygen. So 1 carbon, 1 oxygen, we're going to write it as CO. See how simple that is? Now I want you to pause this video and try the other 4 all on your own. Come back when you're finished. All right, let's see how you did. For number 2, you should have gotten CF4, 1 carbon, and the prefix tetra tells us we have 4 fluorines. 3 should have been N2O3, dinitrogen, meaning 2 nitrogens, trioxide, meaning 3 oxygens. Selenium dioxide is SeO2, because we have 2 oxygens. And nitrogen monoxide should have just been NO. How'd you do? Hopefully really well. If not, you can always go back and try it again. Now, last thing we want to talk about are diatomic molecules. Now, we've mentioned diatomic molecules before, and that's a molecule composed of 2 of the same atom. You must memorize these. These are our Brinkelhoffs, make a 7 on the periodic table with the exception of hydrogen, however you want to memorize them. All of our diatomic molecules are covalently bonded to each other. Now, I want to be clear. This means that hydrogen cannot be by itself. It has to be H2, or it has to be bonded to something else. This does not mean that automatically every time you see a hydrogen or an oxygen, you have to put a 2 next to it. It is only when they are by themselves. All right, come to class, ready to practice with those covalent bonds.